Hello and welcome to this episode of T-Tech. This is part 1 of 3 in our NetBSD Firewall series. I do hope you enjoy it, and let's get into it. Okay, hello and welcome to part 1. So this is where we're going to introduce how this is going to look and the concepts that we have to understand. So with using NetBSD as a firewall, the main thing we're going to do is we have an ISP up here, the Internet Service Provider, and we get a connection from them. Now, this will work across DSL, cable, fiber, or satellite internet connections. And the reason is when they install the modem, most times their side of the modem that connects into their network takes care of if it's fiber, if it's cable, etc. So what I mean is, the other side is just a normal Ethernet cable. So if you can put an Ethernet card in the computer you're using, you can use it. But anyway, all that will be called the WAN, or Wide Area Network. And it's in red here because we don't trust it. And the reason we want to use a firewall is to protect our computers that are behind the firewall from all of that, in like bad traffic potentially. So this link comes into one port on our NetBSD machine here. And on the other side of that, we have our LAN, our local area network. Now it's green because this is what we trust. Now, after that plugs into a switch. This could be an 8-port switch like you buy from Walmart, etc. But from that, those plug into our PCs. You could have an access point here as well. But the PCs are on the LAN side, okay? And if they want to talk, because they're on the same network, they can talk right through the switch using each other's MAC addresses and the corresponding IP addresses. But what we're going to explore is what happens when PC2 needs to get to the internet. How will this all work for us? Well, what would happen is, the scenario is if PC2 wants to talk to Google.com, he sends out a DNS query to a DNS server asking what is the IP address of Google.com. That server responds. That gets him the layer 3 information he needs, the IP address. After he gets that, he has to have the layer 2 information. He has to get off his network. So the layer 2 information means the MAC address that is the LAN interface of our NetBSD machine. So he sends an ARP request and gets an ARP reply from NetBSD, and then he'll put all that information in his ARP cache. So because of that will allow him to send the packet to the switch. The switch, using the MAC address, will send it out the correct port up to NetBSD, and then the NetBSD gets the packet. So, excuse me, the switch will flood it, but that's at the first point when he's trying to find the MAC address of his gateway. So, after NetBSD gets the packet, this is what we really want to focus on. So, what we have in most internet connections, at least for the purposes of this discussion, is you have a public address and you have a private address. Now, the reason this had to happen was, well, we're running out of IPv4 addresses that are unique. Now, the private side, we can use those on any of our networks anywhere. And every network in the world has private addresses on it. Now, the public addresses are unique. There's only so many of them in IPv4. Now, what we have to do is the LAN side of our NetBSD machine is 192.168.1.1, and that's private. And the WAN side, now for my lab, these are private because I already have a network, but that doesn't affect how this operates. And then the WAN side of our NetBSD is 192.168.0.25. Now, PC2's address is 192.168.1.3. And when NetBSD gets the packet, even if it was PC1, it doesn't matter. The idea is he takes that private address from PC2, that's the original source at layer 3, the source address of the packet. He wants to change that address with NAT, Network Address Translation. This is called source NAT or SNAT. And what he's doing is he's changing the source of the packet to actually be 192.168.0.25. So everyone behind the NetBSD machine appears to be coming from the one IP address on the WAN side. All right, that's how we're saving public addresses. And this isn't a security feature. This is only conserving addresses, okay? The firewalling is the security feature, and we'll get into that in a second. So he's changed the address, and then remember how we're going to google.com? So that packet has a destination address of google.com. He takes that address and he's looking in his routing table. That stores all the networks the NetBSD knows about. And any computer has a routing table, even if it's not a router. But anyway, he will find the best route. And in this case, our best route is called a default static route toward our ISP. Okay? So what this machine does is it'll send packets out the WAN. As long as they're not destined for the LAN network, or later on if you add more networks here, it will send it out the WAN. Okay? Once it finds that route, that packet goes out there, and then it gets out to google.com. Now, when the packet comes back, the source NAT actually becomes something called destination NAT. Now, it keeps track of that state, the NAT translation. And now what it has to do is look at that IP address it's destined for, which is the WAN side of NetBSD now when Google replies. And there's also a port number. When you're using NAT, your NAT changes the port number for every outgoing connection to differentiate every computer. So PC1, if he talked, he'd have a different source port number. And PC2 likewise has a different one. Well, we use both of that information, and then it changes 192.168.0.25 as the destination to the destination of 192.168.1.3. You see what we're doing? It's working in reverse. And after that happens, we have to compare the destination address, in this case the PC2's address, to our routing table again. And then instead of sending the packet out of our WAN, we actually send it out of our LAN. Okay? So that's how that works. Remember, NAT isn't a security feature. It's a way to take a lot of PCs on a private side and make them appear to be coming from one address to conserve those public addresses. And the firewalling, in addition to this state here, okay, keeps track of that. When the packet comes out, it makes state. So only the packet, if I send a packet to Google, I'm expecting a response from Google only on the specific port numbers and things. If it doesn't match that in the state table, the packet is dropped. Okay, when we get into part 2, we're going to configure all that. So we're going to have a lot of fun with that. But that is how the firewalling, if it's not expected, it just gets dropped. It's called a stateful packet filter. Stateful packet filtering. Okay, well, that is our introduction. I will see you in part 2, and then we're going to get onto the NetBSD machine and configure all this. So I will see you there. And as always, I'm Tyler with T-Tech, and see you in part 2.